So hi everyone, today we are going to solve this problem. Okay, it's LeetCode problem 2996, smallest missing integer greater than sequential prefix sum. Okay, so now see, we are given an array of integer called nums, and our task is to find the longest sequential prefix of the array. So now what is prefix? Okay, so first understand what is prefix. So prefix means the part of the array that start from the first element. Okay, so let's understand with example. So we have nums of array. So prefix means the part of the array that start from the first element, like see 1 2 3 5. Okay, so some prefix are 1 1 2 1 2 3 and 1 2 3 5. Okay, so see, if we can write 2 and 3, so it's not a prefix because it does not start from the first, okay, element. So now what is mean by, see, yes, sequential. Okay, sequential prefix means a prefix is a sequencer when every number, see, when every next number is exactly one greater than, okay, then the previous number. So let's see, let's for example 1 2 3. So is sequential because see 1 2 3 1 2 plus 1 is 2. Okay, then 2 plus 1 2 plus 1 3. Okay, so see, but if we have 1 2 4, so it's not sequential. Okay, because see 1 2 plus 1, okay, plus 1, then 2 plus 2, and next is 4, so this is plus 2, so that's why it's not sequential. So let's understand this problem. So see, we are given nums of array 1 2 3 2 5. Okay, starting from the beginning 1 2 3. Okay, but 2, see here 2 3 and 2 it's long. Okay, so the longest sequential prefix is 1 2 3. So now we calculate this. 1 plus 2 plus 3 is equal to 6. Okay, so see, we need the smallest number that is greater than or equal to 6, and the and is missing from the array. Okay, 6 is missing from the array, so 6 is not present in the array, so the answer is 6. Okay, let's take another example. 2 3 4 5 14 and 15. Okay, so the sequential prefix is 1 2 3 1 2 3 4 5. Okay, 2 3 4 5. Okay, because see 2 3 4 5 is plus 1. Okay, see, first element is 2, 2 plus 1 is 3, so 3 plus 1 4, 4 plus 1 5, so 5 plus 1 is 6, but here is 14. Okay, so our the sequence prefix is 2 3 4 5, so its sum is 14. Okay, now we check 14 is present, yes. 15 is present, yes, but 16 is not present, 16 is missing, so the answer is 16. Okay, so the final answer is 16. Let's take one more example. 4 5 6 10 and 15. Okay, so the longest sequential prefix is 4 5 6. 4 plus 5 plus 6 is equal to 15. Now 15 is present here, 16 is present, no, 16 was not present, so the answer is 16. Okay, so see, the problem is asking us to do just 3 things. Find the longest sequential prefix. Okay, longest sequential prefix, And next is calculate its sum. Then starting from the total sum, find the smallest number that is missing from the array. Okay, so and remember, greater than or equal to means the sum itself can be the answer if it is missing from the array. Okay, so now that we understand the problem, so how can we solve it? Okay, so see, we can divide the solution in two parts. We find NTI sequential prefix. Okay, sum. First we need to find the longest sequential prefix. Okay, so let's take 5, 6, 7, 20, 21. Okay, so we start from the first element 5, 6, 7. So now see, this only is sequential prefix sum. Okay, so we start from the first element 5, 6, 7. Now we check whether the next number is exactly previous plus 1. Okay, so say 5 is equal to 6 plus 1. So 6 is equal to 7 plus 1. Previous, now like this. See, 6 is equal to 5 plus 1, and then 7 is equal to 6 plus 1, 7. So 20, next element is 20. 20 is equal to 7 plus 1. No, it was wrong. Okay, so as soon as this condition fails, we stop. So our sequential prefix is 5, 6, 7. Okay, now we calculate its sum. So the total sum is 18. Now we can calculate. So see, now our target start from 18. Okay, so our sum is 18 and our target start from 18. So next is find the smallest missing number. So now see, the problem has says find the, wait, let me show you. So the problem has says find the smallest number that is greater than or equal to sum. Okay, so and is missing from the array. So we start checking. Okay, so see, so we start checking 18. So 18 is in the array? No. So 18 is missing, so the answer is 18. Okay, so see, now what is the sum is already present. See, what if the sum is already present? So let's change the example. Let's take another example. Nums is equal to 5, 6, 7, 18 and 19. Okay, so the sequential prefix is still, okay, sorry for pronunciations. Okay, sequential prefix is still 5, 6, 7. Okay, so its sum is 18. So now we check 18 is present in the array. So we move to the next number, that was 19 also present in the array. So we move again to the next number, that was 20. So 20 is not present in the array, so the answer is 20. Got it? So now our idea is complete. First we find the longest sequential prefix, then we calculate its sum, then we start checking from the sum, and this, see, is this number present? Yes, we move to the next number. If no, we return this number. Okay, so the important observation is we do not need to check numbers smaller than the prefix sum. Why? Because the problem is for numbers. So yes, the problem is as for the numbers, that was x is, yes, see, greater than, x is greater than or equal to sum. Okay, so if sum is 18, we only care about 18, 19, 20. Okay, 20, we only care about 18, 19, 20, 21. Okay, so we completely ignore this all. So see, how do we check if number exists? So we have two choices. Simple approach. See, for every number, we scan the whole array. Okay, we scan 18, 19, 20. For 18 we scan the array, 19 we scan the array, and 20 we scan the array. So it's work, but it can take time complexity big of n square. Okay, time, it's take big of n square time. So the optimus approach is we can store all the numbers in the set. Okay, so then we can quickly ask, is 18 present, is 19 present, is 20 present? Average lookup takes big of n, big of 1. Okay, lookup take big of 1. So the overall solution become time complexity is big of n and the space complexity is big of n. Okay, so see, what is your approach? If someone asks you for this problem, what is your approach, you can say like this: first, I find the longest sequential prefix by checking whether every element is exactly one greater than the previous element, and I calculate its sum. Then starting from that sum, I check for the smallest number that is not present in the array. I can use an unordered set for the first lookup. Okay, so now let's write down the code. Okay, so let's take this example. Nums is equal to 5, 6, 7, 18 and 19. Okay, so we already know the idea. Find the longest sequential prefix, calculate its sum. Starting from the sum, find the smallest missing number. Okay, so how do we find the prefix sum? See, we need to start from the first element. So the first element, first we need to start from the first element. Okay, so that's why we write, let's write down the code in sum is equal to nums of 0. Okay, why? Because a prefix containing only the first element is always, okay, always sequential. Wait, let's see here. In sum is equal to nums of 0 means sum is 5. Okay, first element. Now we have to check the next element, so we need to compare every element with the previous element. Okay, so we start from index 1, 0, 1, 2, 3, 4. Okay, we start from index 1. Why? Because we need nums of I and we need to check. Okay, we need nums of I and nums of I minus 1. Okay, for example, say for I is equal to 1, 6. Okay, nums of I is 1, that was 6, and nums of I minus 1, 0, it's 5. Okay, so we need a loop. Let's write me the loop. For int I is equal to 1, is less than nums dot size, then I plus plus. Okay, so see, we have to check the sequential condition. A number is sequential if, sorry for pronunciations. Okay, it's very hard to pronounce this word, sequential, sequential. Okay, see, current is equal to previous plus 1. Okay, we have to check the sequential condition. Current press previous plus 1. Okay, so how can we write this in code? if nums of I is equal to nums of I minus 1 plus 1. Okay, so see, if this is true, the number belong to our sequential prefix. Okay, then we add it to the sum plus equal to nums of I. Okay, so then wait, let me complete this. Else break. Okay, see, 5, 6, 7, 10, 18, 19. Okay, sum is equal to nums of 0, that was 5. Okay, I is equal to 1, 0, 1, 2, 3, 4, 5. I think wait. Now if we break this condition, let's try run with this. Wait, now I is equal to 1, nums of 1 is 6 and nums of 0 is 5. Okay, we check 6 is equal to 5 press 1, yes, and 6 is equal to 6. So sum is equal to 5 press 6, that was level. Okay, now sum is level. Now I is equal to 2, nums of 2 is 7 and nums of 1 is 6. So we check 7 is equal to 6 plus 1, yes, it was 7. Okay, so sum become is equal to 11 plus 7, that was 18. Okay, now I is equal to 3, nums of 3 is 18 and nums of 2 is 7. We check, so 18 is equal to 7 plus 1, 18 is equal to 8, no. Okay, so the sequence is broken. Okay, so we break here, that's why we break. Okay, so our final sequential prefix is 5, 6, 7. Okay, and the sum is 18. So now we have to find the smallest missing number. So we know, so we have sum is 18. So the problem says find the smallest number greater than or equal to 18 that is missing from the array. So see, so we need to check 18, 19, 20, 21, so on. So we store all numbers in an order set. So let's write down UNORDERAD, an order set in ST. Okay, then put every numbers into it. For int num is to nums, insert num. See how it's work. For example, we have 5, 6, 7, 8, 5, 6, 7, 18 and 19. Okay, so it's the set contains on 5, 6, 7, 18, 19. Okay, then we have to start checking from the sum. For this we write while st dot count sum Okay, this means while sum exists in the set, increase it by 1. Okay, so let's try then. Sum is 18 and we check is 18 is present, so now sum is 19, so sum 19 also present, so sum 20 is missing from the array, so the condition become false, so the loop stop. Okay, now sum is equal to 20. Okay, so we return sum. Return sum. Okay, so this is our full code. Let me check once. In sum 0 for row, yes, it's right. Okay, so see, first I calculate the sum of the longest sequential prefix, then I store all element, first we have calculate here, then we have store all element in an order set for first lookup. Then starting from the prefix sum, I keep increasing the value while it exit in the set. The first value does not exit, it exit is the answer. Okay, so that's it. Let me show you what we are doing. First nums. Okay, then we find sequential prefix. Okay, then we calculate the sum, then we have calculated sum, then we have put all numbers in to set. Okay, so start from sum, then is sum present? If yes, sum will increase. Okay, if no, we return the sum. Okay, we just return the sum, that's all. So this is a code.